is Birgitta, and I'm going to talk to you why is keeping water flowing that important. A puddle of stagnant water grows very rapidly murky. This is because stagnant water promotes the growth of microbes. Some of these microbes, however, can make people ill, especially those whose immune systems are suppressed. One we all know about is, of course, Legionella. Let's have a closer look at. It is mandatory to control Legionella in water systems. The regulations in the UK demanding this are the Health and Safety at Work Act and the Control of Substances Hazardous to Health regulations. It is a difficult species to control, though. It exists naturally in water and moist soils and enters water systems through the water supply. There are no restrictions of having Legionella in the water supply because transmission to humans is normally via inhalation, not from drinking water. Legionella also multiplies between 5 degrees and 45 degrees Celsius, but it survives 0 degrees and 63 degrees Celsius. It is just sleeping at those temperatures. Legionella is difficult to control in water systems with oxidizing chemicals, such as chlorine and chlorine dioxide, as these chemicals gas off over distance and at elevated temperatures. It is also difficult to gain control with temperatures greater than 55 degrees Celsius and less than 20 degrees Celsius because these temperatures do not penetrate biofilms well. I will talk more about biofilms later on, as this is very relevant to stagnating water, and biofilms are the major breeding sources of Legionella. Infection by Legionella is by inhaling water droplets with Legionella in it, aerosols. Once inhaled, it can cause severe Legionnaire's disease, which can be fatal, especially in people whose immune system is suppressed. And it can also cause Pontiac fever, which is less severe, with flu-like symptoms. Legionnaire's disease, especially now, as its symptoms can be similar to COVID-19, can be diagnosed too late, which can result in death due to treatment started too late. Treatment is only with antibiotics, not antiviral drugs. Legionnaire's disease is also often underreported, as death is usually recorded due to pneumonia and septicemia, again similar to COVID-19. Another known bacterium that needs to be controlled in water systems is Pseudomonas aeruginosa. Pseudomonas aeruginosa are also found in water, but can be found also on any surface. It grows very well at 37 degrees Celsius, but survives 4 degrees to 42 degrees Celsius. The difference with Legionella is that infection is not only by inhaling water droplets with the bacteria in it, but also by touching surfaces with the bacteria on it. Again, similar to COVID-19. This is how disease by Pseudomonas aeruginosa can be spread so quickly. It can cause all these horrible infections: pneumonia, bacteremia, endocarditis, meningitis, etc. And it can also be fatal. Pseudomonas aeruginosa, unfortunately, are becoming more and more resistant to antibiotics. Another species that can make you very ill and that can kill as well is Stenotrophomonas maltophilia. It's again found in stagnant water and in the environment. It grows between 5 degrees and 40 degrees Celsius. It can survive chlorinated systems. Outbreaks from contaminated surfaces and water systems are known. Infection is again by inhalation of water droplets with the bacterium in it, but also by touch, and it can cause pneumonia, bacteremia, septicemia, etc. It can be fatal, 14% to 69% in patients, and again, it's becoming more and more resistant to antibiotics. Another species that can make you very ill and can be fatal is non-tuberculous mycobacteria. It's found in water and soil. There are 150 plus different species of non-tuberculous mycobacteria. Optimum growth is between 25 degrees and 45 degrees Celsius. There have been cases reported from medical equipment and as well water systems. Infection is by inhalation and aspiration of water droplets with the bacterium in it, and also open skin. It causes lung disease, lymphatic disease, skin soft tissue infections, etc. The infections are rising though, and this bacterium is specifically difficult to control because it's resistant to, for instance, antibiotics because of the lipid levels in the cell wall. And like the other bacteria, it is opportunistic. As I said earlier on, I will talk a bit more about biofilms because biofilms are the major sources of bacteria that make you ill, like Legionella, Pseudomonas, aeruginosa, etc. So what happens is that in the water supply you have all kinds of bacteria, and I said earlier on also, for instance, Legionella. When they hit a water system, the bacteria shrink to spores, these little round circles here. And then until they find the right conditions, they become swimmers, these ones here. And quickly become stickers. And then they multiply and multiply, excrete slime, and form slime houses. They keep on multiplying and they get breakfast in bed from the water and form slime stacks. In these slime stacks, they hide away from, for instance, oxidizing chemicals and temperature. And they even talk to each other, letting each other know when conditions are good for them to leave the stack, the slime stack, and when conditions aren't great for them, so they can protect themselves more in the slime stack. The water flows over these slime stack, and that causes bits of these biofilms breaking up, like here, which is called sloshing. And these bits can nestle downstream, forming more stacks. The persisters keep on hiding in the biofilms and multiplying in them. And some bacteria, when the conditions are right, they swim away, and they swim away to another surface, and they form the stickers again, the small slime houses, and the big slime stacks. And this is how it carries on and on and on. So it's very important that when you control any of these bacteria that can make you ill, that you have something that can actually penetrate these slime stacks and eventually remove them. So where do these biofilms form? In any water system, especially in stagnant water. Microbes love rubber. Rubber O-rings, rubber-lined hoses, rubber membranes of expansion vessels, rubber fittings in non-return valves. Remember, the best growth is between 37 and 45 degrees Celsius, therefore blended water, mixing valves, is where they grow best. The meshes of flow straighteners or flow aerators are also an issue, prone to growth. Sensor tabs are growth areas too, especially because they have these rubber-lined hoses here, and normally a mixing valve is fitted near to it, so they have a temperature at which Legionella, for instance, grows best. Scale is an issue because biofilms can be covered with it, protecting any microbe even more. Biofilms can grow in calorifiers, plate heat exchangers, like here, in tanks, especially with a bit of scale, in cooling towers. Galvanized steel can be an issue because when the protective zinc layer erodes at elevated temperatures or by aggressive oxidizing chemicals, the iron is exposed, rust forms, and tubercles form rapidly. Iron is a nutrient for microbes, and biofilms grow rapidly on it. I've taken this part of galvanized steel pipe from a hospital in the UK. This shows you what can happen with galvanized steel. You can't even look through the pipe, so flow is disturbed as well. Dental lines can be an issue, especially because we are spraying water droplets that could have microbes in it in people's mouths. They're inhaling it. So, we need to keep water flowing to avoid biofilms forming in water systems, because in flowing water, the conditions to form these biofilms are not good for microbes. However, once biofilms have developed in water systems, it is also important to apply the right biocide. A biocide that can kill not only free-floating bacteria that can make you ill, such as Legionella, but also the bacteria that hide and thrive in biofilms, because otherwise they will just continue to thrive. I hope you found it interesting, and I thank you for your time.